first game, we have grab a machine with 4 possible outcomes. We can miss everything in the machine, we can drop our prize, we can win a ball, or we can win a bear. And if we win a ball, we can trade that in for tokens to get other prizes. Let's try our first question. To understand probabilities, we need to know that the sum of all probabilities must equal 1. So we are told that the chance of a drop or a ball win is the same, and we're given the chances of a miss and of winning a bear. So as I mentioned, we use the fact that the sum of all probabilities equals 1, which we can represent like this. And here we say that the probability of missing, of dropping, of winning a ball, and of winning a bear all add up to 1. Our given probabilities are 0.1 and 0.4, which add to make 0.5. And we know that the two probabilities that we've been asked for are the same, and that they must add to make 0.5. So if we divide 0.5 by 2, we get 0.25, and that is the missing probability for our two remaining outcomes. Okay, let's practice with another example. What if the odds were 0.15 for a win and 0.55 for a miss? Now we know that 0.15 plus 0.55 plus 2 times another number equals 1. So 0.15 plus 0.55 is 0.7, and then that subtracted from 1 would give us 0.3, and if we divide that by 2, it equals 0.15, and so in this case, the probability of dropping, or the probability of a ball win, are 0.15. If we have 30 tries, how many times are we likely to win a bear given the probability of 0.1 for winning bears? Now we can find our expected number of bear wins by multiplying our total tries, 30, by the odds, or the probability that we were given, 0.1, of winning a bear. So 30 times 0.1, which equals 3. So with 30 tries, we are likely to win 3 bears. We can use the same pattern every time we're given the amount of tries and the probability of winning. So for example, if it's 60 tries instead, and we had a probability of 0.2, 60 times 0.2, and we would expect to win 12 bears. In our next game, Havoc Highway, we are only allowed to keep our prize if we can solve the probability questions that go with it. And the Funfair has tried to make this more challenging for us and given us our probabilities in a different format. So our probabilities for this game are as follows. So to find the value of x, we'll use the fact that the sum of all probabilities equal 1. So 1 is found by adding 4x to 3x to 2x plus 0. So we can't win a red truck, so our game must be rigged. And then we add 1 more x. 4 plus 3 plus 2 plus 1 more x equals 10x. So 1 equals 10x. So if we divide our 1 by 10, we can find the value of x, which is 1/10 or 0.1. And now we can use this to solve our next question, which asks us to find the probability of dropping. So the probability that we were given for this was 3x. 3 times 1/10 or 0.1 is 3/10 or 0.3. And how about the probability of a miss? We look, and this was given as 4x. Same again, 4 times 1/10 or 0.1 gives us 0.4. To find the probability of not dropping our prize, we will subtract the probability of dropping the prize from 1. And this gives us the probability of anything else happening other than us dropping the ball. So P not drop equals 1 minus P drop, which is 1 minus 1/3, and that gives us 0.7. To find the probability of not getting a blue truck or missing with our grabber, so 2 events this time, we will first find the probabilities of getting a blue truck and missing, and then we will subtract the sum of those probabilities from 1. So P not blue truck or miss is 1 minus the probability of both of them happening. So this was given to us as x for our blue truck and 4x for missing. And we know that x is represented by 0.1, so we have to subtract 0.1 and 0.4 from 1, and that gives us a half, or 0.5. So the probability of not getting a blue truck or missing with our grabber is 1/2, or 0.5. In our final game, Eureka, we explore experimental probability. This machine is a new game at the fun fair where you can win some cute bacteria and microbe teddies, and we've been asked to test it. Our prize is Selly, a friendly bacterium with a bubbly personality that spreads joy wherever she goes. We trial the game, grabbing Selly 100 times. Out of these 100 tries, the claw dropped her 90 times. To find the probability that the claw held on to her, and we won her as a prize, we'll use the concept of experimental probability. Now, experimental probability is found by dividing the frequency of outcomes by the total number of trials. So for us, this means we need to divide the number of successful grabs, which was 10, by the total number of tries, which was 100. So again, we find our answer to be 0.1. What if the claw instead had held on to her 7 times? Then what would our probability be? Now we would just divide, again, our number of successful tries, 7, by 100, giving us 0.07 as our probability. If we tried 500 times to hold on to our prize, given our original success rate of 0.1, how many times would we expect to win? So how many Sellies would we get? So our expected number of wins we find by multiplying our total number of tries by the probability of winning. So the total tries was 500. Our probability was 1/10, or 0.1. Multiply these two together and we get 50. Finally, over 1,000 tries. What would the experimental probability be of a win if we won Selly 25 times? So we find our probability of winning by dividing the number of successful grabs by the total number of tries. We had 25 successful grabs, we had 1,000 tries, and we find the answer here therefore to be 1/40th. So the experimental probability of winning Selly over 1,000 tries in this case is 1/40th.